All right. Chapter 13 is just about experiments and observational studies. And really, it's just about experiments because we're going to spend about one slide on observational studies. Okay, so again, it's mostly definitions and how to use the definitions. And most of the chapter is just being able to design an experiment or identify what type of study something is. So chapter 12 is all about surveys. That's a type of study where you're asking people questions, right, polling people, etc. And we're going to talk about observational studies, and then we'll spend today and then tomorrow talking about experiments. Tomorrow we're going to do an activity in class so you can actually see how you would plan an experiment. Okay? Yes. Mm-hmm. All right. So, an observational study, okay, is where you are just simply observing. Now, observing can mean different things, but you're not actively doing anything with any of the participants in your study. All right? That's going to be the biggest difference. So in an observational study, you're going to identify your participants, and then you're going to observe some behavior. Or you're going to look at their records. Or you're going to, like we'll look at an example later, you're going to use samples that already exist and look at how that's related to some other variable, right? You're not actively doing anything with anyone. So you're not manipulating anybody. You aren't really generally talking to anybody. You're just observing something. You may or may not know you're part of an observational study. Okay? So there's two types of observational studies. One is a retrospective study, and one is a prospective study. All right? Retrospective means you're going to identify people first, and then collect data, generally data that already exists. So maybe I want to know how, I don't know, this book has an example, so I'll use theirs. Has, like, how band or, like, being in the orchestra or something is related to your grades. Well, so I would identify, like, all of the band members at Murray High School, and then I would go back and look at their records. Like, maybe I wanted interested in, like, their freshman year or something. All right? So you're just identifying a group of people, and then you're going back and looking at something that already exists. That's generally retrospective. That doesn't do much for you, though. A lot of observational studies are over time. So that's a prospective study. That's where you identify subjects in advance and collect data as events unfold. It's up here. You identify subjects and then collect data as you go. So same scenario. Let's say I want to know how, like, again, band or orchestra influences your grades. Well, then I would identify the freshman class now. All right, freshman class now that are in band. And I would go through and look at their grades at the end of this. Then I'll go back and look at their grades again in sophomore year. And then look at their grades at the end of their junior year, senior year. So I'm identifying people. I'm going to be using data that doesn't exist yet. Right, so doing things over time. But generally, if you're trying to figure something out, it's going to take time anyway, right? So a prospective study, you're going to see how something like progresses over time. Maybe you identify people and take some sort of measurement or look at something at the current time, and then you wait 20 years, and then you catch up. All right, that would be prospective as well. Okay? But remember, in an observational study, these people are, like, just an example I just gave you, I'm not, like, actually doing anything with these people. Right? Like, you guys maybe wouldn't even know that you were involved in my study. Because I don't have to talk to you. I'm not giving you a survey. Right? So I'm not talking to you. I'm not putting you into groups to do an experiment with or anything. I'm just identifying those people and then using records or something that already exists or are going to exist. I'm observing. Questions about retrospective or prospective studies? All right, and that's about all we got for observational studies. Just knowing what they are. There's not much to it. Okay? So the rest of this chapter is about experiments. So, we want to do always a randomized comparative experiment, and we will go back and talk a lot about that tomorrow. All right? But if you are going to take people or plants or animals or whatever, and you're going to put them into groups, and you're going to manipulate them in some way, then you're doing an experiment. So an experiment involves some sort of manipulation. I'm not meaning like psychologically. I'm just saying like you're going to somehow do something. Like you're going to like tell these people to take this supplement and these people take this supplement. Or you're going to tell these people to exercise by doing this for 2 weeks and then exercise by doing this for 2 weeks. All right? So you're somehow manipulating the situation. You're manipulating it so that somehow you can compare two things, probably. An experiment requires, like has to have, random assignment. So for example, the easiest experiment I can always think of is like those experiments you did in middle school with like plants and sunlight. Right? Those are really easy to think about. Right. It always pops into my mind. So if I'm talking about random assignment, if I'm talking about this experiment, then we have like plants, probably the same, definitely the same type of plant. So I don't know what kind of plant, but some plant. All right. Or some flower. And we want some in full sunlight and some in half sunlight and some in no sunlight. We're going to measure growth at the end, right? That's that middle school experiment I'm thinking of. All right, so random assignment means I go and I buy 15 plants from Lowe's, all right, of the same type. Probably seeds, right? So I buy a packet of seeds. When I put those seeds into cups and then put those cups in those groups, I'm going to randomly assign which plant goes into which group. Why would it be important for me to randomly assign which plant goes to which group? Why might I want to do that? Why might I randomly assign plants to groups? Well, do you know that all the seeds are going to germinate? No, right? So by randomly assigning, we're kind of equalizing the playing field, right? By randomly assigning, then we're just saying, I didn't like pick certain ones, whatever. I'm just putting them here and here and here. I'm trying to get rid of any like bias or any like underlying factor I might not know about by randomizing. All right? Okay, so randomizing is going to be an important step. Now, obviously, an experiment measures a relationship between two or more variables. So you have at least one explanatory variable. You might have multiple. And in an experiment, we call that a factor. So an explanatory variable is a factor. And then we have at least one response variable that we're going to measure at the end. So in my plant experiment, the factor is the amount of sunlight. That's what I'm manipulating, right? And then the response variable is going to be the growth, so how tall the plant is or whatever at the end. Everyone understand what a factor is? Response variable. Now, what distinguishes an experiment from other types of investigation? Again, the experimenter is actively and deliberately manipulating factors. Right? So that's why I said manipulating. That's why it's different from an observational study or a survey. Right? You're trying to control different aspects of the scenario. So that means you have an experiment. All right, some more vocabulary. The individuals on whom or which we experiment are known by a variety of terms. So humans are called subjects when they're in an experiment. You can also call them participants. We use subjects a lot more often, though. And then like plants and animals and bacteria and things are called experimental units because subject indicates that they have like an opinion about the matter. So humans are subjects, and then animals and plants are experimental units. The specific values that the experimenter chooses for a factor are called the levels. So levels means the different things that are happening within the factor. So in our plant experiment, I said that some plants are going to have full sunlight, and some are going to have half sunlight, and some are going to have no sunlight, right? Well, that's one factor, amount of sunlight, with 3 levels. Right? One factor, 3 levels. Does that make sense? So it's just the different types of what's happening in the factor. And we'll do a lot more practice with this tomorrow. And then the combination of all the levels from all the factors is called a treatment. That's going to be your groups for your experiment. So I can do 2 examples. One is our plant experiment we've been talking about. It has one factor, sunlight amount, with 3 levels, full, half, and none. Right, there weren't any other factors. We're just worried like we're only manipulating sunlight. We're going to give all the plants the same amount of water and the same amount of food, etc., right? So because of that, there are 3 treatments. So that'll be a full sunlight group, a half sunlight group, and a no sunlight group. And I would randomly assign however many plants I have and do all those groups. At the end, I would measure how tall they grew, right? Let's do one that has more than one factor, though. Because when you have more than one factor, then you have the treatment's a little tricky. What if I have an experiment about diet and exercise? All right, I'm going to manipulate both of those. So I'm going to have 2 factors. I'm going to manipulate people's diet, and I'm going to manipulate their exercise regimen. So I have 2 different things that I am messing with. Let's say that there are 3 diet plans, A, B, and C. That means there are 3 levels for diet, right? And then for exercise, there's 2 exercise plans, A and B. That means there's 2 levels for exercise, right? 2 factors. One factor has 3 levels, one has 2 levels, all right? If you multiply the levels, that's how many treatments you should have. So 3 times 2 is 6 treatments. So I would have, you don't have to write all these down, but I would have diet A and exercise A, diet A and exercise B, diet B and exercise A, diet B and exercise B, C and exercise A, and diet C and exercise B. Right? That's all the combinations of all the different levels. And then so I have 6 groups, 6 treatments, and I would take all my participants and randomly assign them to those 6. Does that make sense? So do we understand what a treatment is? a factor, and a level. Those are important to keep separate. Okay with that? Again, we'll do more experimental design tomorrow. We're actually like doing diagrams of things. We're not doing that today. 4 things you want to keep in mind. You want to have some aspect of control, and we can talk more about like specific controls tomorrow. But we, in general, not like an actual control group. We'll talk about that tomorrow. In general, we want to control sources of variation. All right. So yeah, we might be testing the amount of sunlight our plants get, but we want to make conditions for the plants as similar as possible for everything else. So we want to give them the same amount of water each day. We want to give them the same amount of food each day, right? We want the temperature to be the same, right? So we want to control everything else that's happening, if possible, outside of what we're manipulating. Does that make sense? We just want to reduce all the variability that could happen. So we don't want to do our sunlight experiment in 3 different rooms where one room is 20 degrees and one room is 40 degrees and one is 60 degrees. I think one of those rooms has full sun, one has half, and one has none, because then we have issues. Now we aren't controlling the variation that's happening. All right, now we have temperature as another factor that we weren't anticipating. Okay? We definitely want to randomize. Again, that allows us to equalize the effects of unknowns. Like, I shouldn't pick an experiment. Like, if I was going to do an experiment on you guys, I don't know what kind of experiment, I don't know. But I shouldn't pick all the people that are friends to be in a group. They probably have things that are in common, and so now I have all these people that are in common, and maybe that's different from the other group, and we just want to randomize, randomly select. We want to replicate the experiment in 2 ways. Right? One way, we need to have multiple subjects or experimental units per treatment. I'm not going to do my diet and exercise example with 6 treatments and have 6 people. That's not going to cut it, right? So I need to have multiple people in each one of those treatment groups. I also need to repeat the experiment. You can't prove that something's related after you do the experiment one time. That ain't going to cut it, right? It could be an anomaly. It could just happen by luck. So you want to repeat the experiment over again after you've already completed it to show that your results weren't just this one-time thing. Okay? So maybe you want to repeat the experiment under different conditions to make sure the same things hold true, right? But you'll have multiple people in each group, and then after you finish something, you probably want to replicate it again some other time. And the last thing is blocking. Now the first 3 things you need to have, right? Like these are like not optional. You have to control sources of variation by making all the groups have similar conditions, all right? You have to randomize to reduce variation. You have to replicate the experiment or you won't have enough data, and what if something happens to that one person in your group, then you don't know what happened in that group anymore, right? So you have to have replication. Blocking is the only thing that's optional out of these 4 things. So sometimes there's attributes that we are not studying that we can't control and may affect the outcomes of an experiment. All right, so for example, I'm doing the diet and exercise experiment, and it looks like at the end that men and women had different results. Okay? Well, if I didn't think about that ahead of time, I can't compare men and women at the end anymore, because maybe some groups didn't have women, some groups didn't have men, just because of random assignment. Okay? So what I could do is I could block the experiment by gender. So blocking just means we create groups ahead of time, and then we do the entire experiment within each group. All right? So if I wanted to block that diet and exercise example, then I would get an entire group of females, an entire group of males, and I would do the entire experiment, all 6 treatments just with women, and all 6 treatments just with men. All right? So at the end, I can compare the results within women and within the men group, but then I could also compare across between women and men. All right? So an easy way to think is Stratifying is to samples as blocking is to experiments. All right? Stratifying puts people into groups for samples, and you pick a few from each group, right? But it puts people into similar groups. Blocking puts people into similar groups, and you do the entire experiment for all those groups, right? You're putting people together that have similar qualities. Same reasoning, all right? Tomorrow when we do our activity, hopefully you'll be able to see why blocking might be important, okay? Now, you stratify samples and you block experiments. They do it to you on purpose. On the AP exam, they'll have questions and multiple choice, and they'll say, stratify the experiment by, and then the next choice has block the experiment by. They're just trying to test to see if you know what you're talking about. All right, that's just vocabulary, okay? So stratifying goes to surveys, and blocking goes to experiments. Got it? Okay. Well, I'm going to do 2 examples really fast, and then I'll give the assignment. But these are really fast examples. For a stats class experiment, researcher Jay Gilbert decided to study how parents' income affects children's performance on standardized tests like the SAT. He proposed to collect information from a random sample of test takers and examine the relationship between parental income and SAT score. Is this an experiment? Is he taking people and putting them into groups and manipulating some aspect of that? No. So it's not an experiment. He is collecting information. Right? If they're collecting information, then what kind of study is that? Observational study. We would need probably a little more information to say if it was retrospective or prospective. It doesn't say if he is going to use an SAT that's already been given, like 5 years ago. He doesn't say if it's going to do the group that's taking it next month. He doesn't give me any information. All right? So we're just going to say observational study. But does everyone understand why it's not an experiment? Okay. If there is a relationship between parental income and SAT score, why can't we conclude that differences in score are caused by differences in parental income? The only way, so far in this class, we can't ever show cause and effect relationships, right? Never. Like this class, it's not allowed. The only way you can get close is through an experiment. Because through an experiment, you're directly manipulating what's happening, and so you can hopefully control all the other variables, except for the ones you're testing, and then you can show that one variable causes the other variable. All right, but even then, you have to do the experiment multiple times to come up with anything to prove anything. So far in this class, we're still not probably going to prove anything, but we can get close with an experiment. This is an experiment, though. So since it's not an experiment, the best we can show is there's a relationship, like an association. We can't show that something causes the other. Does that make sense? So be careful about the wording here. We would just need to say, no, it's not an experiment, so we can show there's an association between the variables, but not a cause and effect relationship. All right, last one. Researchers studied the herb black cohosh as a treatment for hot flashes caused by menopause. They randomly assigned 351 women aged 45 to 55 who reported at least 2 hot flashes a day to one of 5 groups. And you have these 5 different groups. They're all different supplements. Blah, blah, blah. Okay. After a year, only the women given estrogen replacement therapy had symptoms different from those of the placebo group. All right? So what kind of study was this? This is definitely an experiment. You're taking people and putting them into a group. And each group is getting something different, so something's being manipulated. Is that an appropriate choice for this problem? I mean, could he have done it with a survey or an observational study or something else? Now, if we're trying to measure the effects of these different supplements, right, we would need to see the effect of each supplement on a group of people. All right, you can't just ask people, what are you taking? Is that helping? That doesn't do anything for you, right? An experiment is the only way you can be able to compare the results at the end. Who were the subjects? Yeah, the 351 between 45 and 55 reported at least 2 hot flashes a day. And then identify the treatment and response variables. So how many treatments are there? many groups are there? 5. There's one factor, the supplement taken, right? With 5 levels, and so there's not any other factors, so there's just 5 treatments. If we were going to identify them specifically, we would give all these names that I underlined, but I'm not going to do that right now. It's on the screen. We can all see them. And then what's the response variable or variables? What are they trying to see at the end? Right, they reported at least 2 hot flashes a day, so I'm assuming we're trying to reduce hot flashes, right? So we're probably going to measure the amount of hot flashes compared to the beginning, yada yada. Questions about that? Okay.